The work title Proposal for Integration between Computational Fluid Dynamics and Project-Load Education, Updating of Mechanical Engineering Curriculum Profiles in Pernambuco, Brazil. So, the computational fluid dynamics (CFD) techniques were integrated in the aerospace industry, a system analysis that emerged from the union of fluid mechanics, heat transfer, and numerical math disciplines. This methodology is used worldwide in the design, research, development, and manufacture of new products. Thanks to its versatility, it also reduces the time and cost of new projects, as well as allowing to break the behavior of systems subject to extreme operating conditions that exceed normal safety and performance limits. At the same time, the Project Lead Education (PLE) approach is focused on giving students great challenges with increasing difficulties and challenges questions with the aim of creating and optimizing products, applying theories in their development with a long duration for the development of the proposal. The POE starts from a project suggested by the teachers and the development of a product through the participative work developed by a team of students leading then to the collect data, information, generate ideas, and to identify their learning needs. Thus, it smatifies the tradition of lectures very present in Brazilian universities. Uh, the current form of education, especially in Brazil, is focused on the exposition of knowledge, have a direct participation of the teacher and very small of the students. Thus, this work aims to propose an integration between the CFD techniques and PLE approach, which can guarantee to the students new knowledge in the areas of engineering and expertise in increasingly present software in the industry, the answers. So this iteration will guarantee a much more agile methodology, which, in addition to favoring teamwork, can also reduce avoidance in engineering courses, since the learning process will be much more dynamic. So, the process of elaborating a project in safety basically follows the same steps. It starts with the generation of a geometry in computer eye design. It generates a mesh that is a discretization of the computational domain. Preprocessing is performed where the contour models and conditions are chosen. The process of the interactive numerical calculation is monitored, and finally the results as analyzed in post-processing. So the first unit of the discipline will serve to expose of necessary knowledge on fluid mechanics and heat transfer. In parallel, is suggest the teacher advise the student to be divided into teams and to distribute of the teams of the projects so that students become familiar with the problem and understand their possibly models and their boundary conditions. Um, the second unit will be totally focused on the elaborating of the computer simulation project, in which the teacher will assist the student, helping him at first with suggestions of simplification of geometry and discretization of the mesh. As for preprocessing, it suggests that the teacher encourages students to seek more knowledge about fluid dynamics in order to better understand the models that can be chosen. Finally, the post-processing step can be done qualitatively and qualitatively, and it can be used also from the literature. It's it is recommended that the evaluation is not done by the final project result, but by the student progress and how he solved the problem during the process. A monitoring worksheet can be applied for the weekly monitoring. Uh, this FD is an important computational tool that has been growing more and more in the industry of the year. Encourage the integration of this technique together. The POE approach can serve as a differential in the professional life of the student. Uh, it can also act as an incentive to student protagonist teamwork and reduce the avoidance of mechanical engineering courses in state of Pernambuco, Brazil. Thanks.